Everybody, very good evening. Welcome to the most comprehensive preparation platform for all competitive exams, BYJU'S Exam Prep. And warm welcome to the GATE 2024 Fundamentals series. In this series, we were learning the C programming from scratch. This C programming language is very useful in your academics, for the GATE exam, for ISRO BARC kind of exams, for NIELIT kind of exams, and also for PSUs, also for your interviews. So guys, this is C programming language you want to learn from the scratch, then this is the right series for you. So try to watch all these classes in regular so that you will understand the connectivity from one topic to another topic. You will understand the flow of subject. Along with this, if you add your practice, definitely you can be confident in this C programming. So, I am Satya, welcoming you all for this GATE 2024 Fundamentals of C programming. Those who have joined, please confirm my visibility and audibility. Is it fine for everybody? Let me welcome Mani Shankar Tiwari. Very good evening. And everybody, please confirm, am I visible and audible clearly or not, so that we will be starting today's session. And in today's session, we are going to discuss the very important topic of C programming, that is how to find address of an element in arrays. How we can find the address of an element in the arrays. This is definitely very important because based on this topic we have got multiple times questions. Okay, so I request everybody to join the session quickly and keep liking, keep sharing the session. Okay, chalo. So, how to find address of an element in arrays? Before I start, let me introduce myself quickly. I am Satya, research scholar with 15 plus years of teaching experience and all the other credentials you can see here. Right. So, all dear GATE aspirants, there is a very good news for you. Our BYJU'S exam prep is conducting national level scholarship test for the GATE exam, GATE aspirants. Through this scholarship test, you can avail up to 90% off on all our programs. And this test is going to be on 14th May at 12 p.m. So, if you are a GATE 2024 aspirant, you have not joined our course yet, hurry up, register for this scholarship test and avail up to 90% off. Okay, chalo. In the last class, we have discussed about two-dimensional arrays. In that, we have covered how to declare a 2D array, how to initialize the 2D array, and what is the difference between row major order and column major order, and how you can give dynamic input for the 2D array elements and how you can print the 2D array elements. And then I have given the pseudocode or algorithm or procedure to find out and print the matrix addition and reverse of the given matrix. And the coding part I have left for your practice. I believe you have tried and you did it successfully. If not yet, please do it once you are free. And also, if you face any difficulty, then don't hesitate to post your difficulty in the chat box or in the Telegram group. Okay, great. So guys, today, as the topic suggests, what we are going to learn? How to find address of an element if indexing starts from 0. For 1D array, how do you find the address? And for 2D array, for 2D array, how do you find the address? On the same way, indexing need not to start always from 0, because gate questions point of view, if you try to understand, the indexing can start from any other value. If so, how do you find the address of an element in the 1D array as well as in the 2D array? So this is what today we are going to learn, and I believe after today's class, definitely everybody feel comfortable in finding the address of element, whether the index start from 0 or any other specified index for both 1D and 2D arrays. Okay, first of all, just give me a moment once. Okay. Yep. First of all, if we take one-dimensional array, we have already seen how do you create a one-dimensional array. We can create integer array or character array or float array, because the data type can be any fundamental data type. Even of course it can be derived data type also, but let us first understand for the basic data types. So let us say I have created one integer array of 5 elements, or character array of 4 elements, or float array of 5 elements. We know that for the character, the size of character is 1 byte always in C programming. Similarly, for the float array, the size is 4 bytes always, right? And let us suppose I am using a 16-bit processor, so the size of integer I would like to consider as 2 bytes. Okay, but guys, this is very for old processor it is applicable. Today you don't see 16-bit processor. Just for better understanding, I am taking integer size as 2 bytes. But when it comes to the gate practice or regular practice of your C programming, you will experience 4 byte or 8 byte for integer. So please keep that in mind. Here for the distinction purpose, I am taking the integer size as 2 bytes. Okay, if so, as I have declared 5 integers, total 5 into 2, 10 bytes space would be allocated at consecutive location. And as I have taken 4 character arrays, 4 into 1, 4 bytes would be allocated at consecutive location. And as I have taken 5 real number array, 5 multiplied by 4, 20 bytes would be allocated at consecutive location. And internally we can say they are organized into 5, 4 and 5 respectively. If I am taking the starting address where the memory is allocated for integer array as, let's say, 1000, for character array as the 2000, for float array as the 3000, the address of next element for integer would be 1000 plus 2, 1002. Next element would be 1004. Next element would be 1006. Next element would be 1008. In the same way, for character, 4 bytes, first element address is 2000, next element address 2001, next element address 2002, next element address 2003. On the same note, for float array, every element occupy 4 bytes. So the first element address I have assumed as 3000. So second element address would be 3004. Next element address 3008, 3012, 3016. Isn't it? So here if I am taking the index as the default index, if the index starts from 0, for each array, if I am taking the index is starting from 0, these are what the indices we will have. That indicates address of first element is equal to 1000, which is base address we say. Similarly, address of y of 0 is 2000. This is again base address. Address of z of 0 is 3000. This is again base address. Base address means address of whole array. Right? Right? Now, if I want address of x of 3, as it is a small array, we can draw the complete array, we can illustrate it, and we can easily find out what is address of x of 3 as 1006. Similarly, what is address of y of 2 as 2002. Address of z of, let's say, 4 as 3016. If it is just having 5 element, 4 element, 10 element, 20 element, just a small number of elements, if the array size is small, we may illustrate complete array and find out address of any element. But what if in real, let's take employee array in a company. There can be thousands of employees. Similarly, student array for a college. There can be thousands of students. Similarly, citizen array maintaining by the government. There will be lakhs of citizens, even crores of citizens. Right? So, when the size of array is very big, like this, to draw complete array and finding address of particular element is definitely time taking process. So, there should be some easy method or some generic method to find the address, definitely. I am talking about 1D array for a while. Just very soon we will talk about even 2-dimensional array also, right? If the array size is very big, definitely finding the address in this brute force method is a very troublesome procedure. So, suppose I am taking an integer array A with 5 elements initialized 10, 20, 30, 40, 50, right? And if the indexing starts from 0, then A of 0, A of 1, A of 2, A of 3, A of 4, you can see values are stored as it is in the order of initialization, and I have assumed the base address as 1000 here. So 1000, the next element address is 1004, because here I am taking 4 bytes for integer. Then the addresses would be like this. So please observe here, when the base address is B is 1000, when I want address of A of 0, this is 1000 plus 0, I can say. Okay. If it is address of A of 1, this is what? 1000 plus the next element address and the base address differ by how much? By 4. Address of A of 2, base address and this second element address differ by how much? 8. Similarly, fourth element address and the base address differ by 16. That means I can write this 4 as 1 into 4. I can write this 8 as, instead of 8, may I write it as may I write it as 2 multiplied by 4 instead of 8. Similarly, instead of 16, can I write it as 4 multiplied by 4? So please observe, 1000 and this 4 are always being constant while finding the address. What is changing? The index. What index whose address you wanted to find, that index multiplied by what this 4 is. This 4 is nothing but size of an integer, and what this 1000 is, base address. So here, if you observe this phenomenon, we can easily get the general formula. What? Address of x of I, if x is an array, address of x of I is equal to base address B plus I. What is I? Index multiplied by n. What is n? Size of each element. Right? So here B is equal to base address, I is equal to index, and n is equal to size of each element. I believe this is clear for everybody to find the address, and this is the default, guys, starting the index from 0, which is default, right? But what if I would like to start an index from 1? I would like to start the index from 1. If I start the index from 1, first element address is 1, second element address is 2, third element address 3, 4, 5, right? And I am taking the addresses as 1000, 1004, 8, 12, 16. Here, if I would like to find out the address of A of I, what was the general formula we have used? Base address plus index into size of each element, right? So will that work now? Address of A of 1 I would like to find out. What is address of A of 1 actually? 1000. But if I use the formula, base address is actually 1000. So this becomes 1000 plus I is 1 into n is 4. So it is giving 1004. But actual address I got is 1000. So both are not matching. That means whenever the indexing is starting from 1, this formula is not applicable. Then let's see how it is actually. Address of A of 1 is 1000. Address of A of 2, when the base address I have taken as 1000 and this address is differ by 4, second element address. Third element address is differ by 8. Fifth element address is differ by 16. Isn't it? So can I write it as 1000 plus 0 into 4? Similarly, can I write 4 as 1 into 4? 3 as 8 as the 2 into 4 and 16 as 4 multiplied by 4. So please observe this. If I am having the index as 1, I am having 0. Index as 2, I am having 1. Index 3, I am having multiplying with 2. Index 5, multiplying with 4. So if I am having index as I, with what I multiply? Not with I, with I minus 1. Now you keep I minus 1 when you are multiplying instead of I. Now you are getting the actual correct addresses 1000, 1004, 1008, 1016, right? So if the index is starting from 1, if the index is starting from 1, instead of I, what you have to do? I minus 1. I minus 1 when the index starts from 1. Okay. Why? Just for the problem's sake, you may be given that index is starting from 5. Base address is, let's say, 1000 itself. So start the index from 5. So first element index 5, second element index 6, next element 7, next element 8, next element 9. And base address I am taking as same 1000. So now 1004, 8, 12, 16. Now I if you take base address plus I into n, 1000 plus 5 into 4, 1020 is what you are getting as address of A of 5. You are getting as 1020, but actual address is 1000. So both are not matching. Okay. So do I take as I minus 1? I minus 1 multiplied by n means what? The general formula we have used for indexing from 1. If I take that, now will I get 1000 plus I is 5. So 5 minus 1, 5 minus 1, 4 multiplied by n, that is multiplied by 4, 1020, which is again not equal to, 4 into 4, 16, which is again not equal to 1000. So I multiplied by n, you are not getting the correct address. I minus 1 multiplied by n, you are not getting the correct address. Then how I am getting it? See, address of A of 5 I want, that is 1000, right? Okay, okay. Carefully observe. Address of A of 6 is differing by 4 from the base address. Address of A of 8 is differing by 12 by the base address, right? Isn't it? So can I write this 1000 also as 1000 plus 0 multiplied by 4? Yes. Can I write this 4 as 1 multiplied by 4 and 12 as 3 multiplied by 4? That means how this, when the I value is 5, how it becomes 0 with which we are multiplying? It is 5 minus 5. Similarly, how it is becoming 1 when the index is 6? 6 minus 5. Index is 8, I am multiplying with 3. 8 minus 5. So, if the index is starting from 5, I am always subtracting with 5. I am always subtracting with 5. So, instead of I or I minus 1, what I take? I minus 5. So, if the index starts with 0, I minus 0 with which we are multiplying. Index start from 1, I minus 1. Index start from 5, I minus 5. Index start from k now. Okay, let us take, if the index is starting from negative, sir, is it possible? In real, I can say not, but for the problem's sake, it may be given. So, let us take minus 3, minus 2, minus 1, 0, 1. Index is started from minus 3. Addresses, again I am taking the base address as 1000, size of each element as 4 bytes. If so, these are what the addresses. Now, will that work? Base address plus I minus k multiplied by n when the index is from k. Let us check. Address of a of minus 3 I want 1000 plus 0. Sorry, what is I? I is what? Minus 3, with which, whose index I would like to find out. Yes, minus 3 minus k is what? Minus 3 multiplied by n. So, 1000 plus minus 3 plus 3, 0 multiplied by 4. So, it is 1000 only. Okay. Let me take address of a of let us say 1. What is address of a of 1 as per this? 1016. Do I get as per the formula or not? Let us see. 1000 plus, here I means 1 minus k means minus 3 whole multiplied by 4. So, this is 1000 plus 1 plus 4, 1 plus 3 multiplied by 4. This is 1000 plus 4 into 4, which is 1016. Yes, 1016 correct. So, if the index starts from minus 3, what I have to do? B plus I minus of minus 3. So, if the index starts from k, what I can take? Base address plus I minus k multiplied by n. So, now you got for any index, whether index starts from k or 0 or 1 or minus 2, any number now you take, any integer number you take, index can never be real. Please remember, any integer number you take, then definitely this formula work. And sometimes you may be given base address is starting from not 1000, some other negative address. Address cannot be negative, but maybe for the problem's sake you may be asked to find out, then still this formula works. Okay? Am I clear, everybody? So, how do you find the address of any element? When the base address can start from any number, index can start from any number, size can be any, array can be any data type. With this formula, you will definitely be able to find out any address. Are we clear? Everybody please respond. Right. Guys, if you understand finding address for one dimensional array, any other array Any other dimensional array address finding is very easy. Very easy. Because you may take 2-dimensional array, 3-dimensional array, 4-dimensional array. They are combinations of 1-dimensional arrays, guys. Every 2D array is combination of 1D arrays. Every 3D array is combination of 2D arrays. 2D array is in turn combination of 1D arrays. So 3D array you can take a big set of 1D arrays. So 1D array is the basic. If you understand 1D array, any other dimension you will be able to understand easily. Okay. So let us check with 2-dimensional array. With the 2-dimensional array, we have learned that in the last class, 2D array can be stored in memory in either of the two ways: row major order, column major order. Row major order means row wise. First row stored, then second row, then third row, and so on. Column major order means column wise. First column values are stored, then second column values, then third column values. Definitely the address is different. Last class I have shown you. Let's say I am taking 4 bytes for integer. Let 4 bytes for integer and base address is 1000 if you take. Then the addresses would be like this: 1000, 1004, 1008, 1012, 16, 20, 24, 32, 40. Total 9 elements I am having. Did I miss any? 28, sorry. Oh, I have written wrong here. 28, 32. 24, 28, 32. Yeah. So these are what the addresses. If I take column major, addresses remain same. Addresses will not change. But what values are getting stored, that changes, isn't it? Guys, keep responding please, Money and everybody. Keep responding. So addresses remain same, but what gets stored, that is different. Like for example, at 1008 address, in row major order, what value stored? 3, but on the same address, 7 is stored in the column major order. Similarly, at 1020 address, 6 is stored in row major, but 8 is stored in column major at the same address. So consecutive element addresses will be same, but what values are stored, that is definitely going to be different, isn't it? So if I am taking a 2D array with row major order, and the 2D array is this: A of 2, 3, 2 rows, 3 columns. So total 6 values I have initialized like this. Let us take 1000 as the base address. So these would be the addresses. Here, how I am getting address of A of 0, 1. That is actually 1004. That is 1000 plus 4. So shall I take it as 1000, which is B base address, plus 1, which is J into 4? No. Can I write this as 1000 plus 0 multiplied by number of columns 3 plus column index is 1 whole into size of each element is 4. 0 into 3 is however 0 plus 1, 1 into 4, 4, that is again 1004. If you have some discrepancy, let us take 1, 2. 1, 2 address is actually 1020. Can I write this as 1000 plus 1 multiplied by how many columns? 3 columns, plus column index is 2 whole into 4. 1 into 3, 3 plus 2, 5. 5 into 4 is 20. 1000 plus 20 is 1020. So, here I can take the general form in this way now. B, which is base address, plus I, which is row index, into C, number of columns, plus J, column index, whole multiplied by N, size of each element. So, here what these letters indicate? B means base address, right? I means row index, J means column index, C is total number of columns, N is size of each element. Right? Okay. I have taken row index, column index starting from 0. Fine. Let me take row index, column index starting from 1 instead of 0. Instead of 0, let me take from 1. Okay. So, 1 row index, column index, both are starting from 1. So, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Oh, sorry. Two rows, 3 columns, no? 1, 1, 1, 2, first row, second column, first row, third column. Similarly, second row, first column, second row, second column, second row, third column. Addresses are same: 1000, 1004, 1008, 1012, 1016, 1020. I am taking base address as 1000. Okay. Now, you please observe here. If I take the formula base address plus I into C plus J whole into N, if I take that, do I get, this is for the address of A of ij. If I take address of A of 2, 1, actually what is address of A of 2, 1? 1012. Let us apply this formula and see, is it equal to 1000 plus I is 2 into number of columns 3 plus J is 1 whole into 4. This is 1000 plus 2 3s are 6, 6 4s are 24. Is 1024 and 1012 are same? No. So, this formula will not work if indexing start from 1. Instead, can I write it as 1000 plus, what is the logic we have applied for one dimensional array? Instead of I have taken I minus 1 plus, as here two indices are there, I, J, row index, column index. So even for column index apply J minus 1 because indexing started from 1 for both row index and column index. Then it would be 1000 plus I minus 1, address of A of 2, 1 I am finding out. 2 minus 1 into number of columns 3 plus J minus 1, 1 minus 1 whole into 4. So this is 2 minus 1, 1 into 3 plus 0, 3 into 4, it is 1012. Yes, it is correct. So if I take indexing from 1, what would be the formula? Instead of I have to take I minus 1, J minus 1. I minus 1, J minus 1. Similarly, you start index from 5. Now you can guess. I am starting both row index, column index from 5. There are 2 rows. So 5, 5, 5, 6, 5, 7. This would be the row, first row value, first row indices. Second row index 6, 5, 6, 6, 6, 7. Addresses are 1000, 1004, 1008, 1012, 1016, 1024, 20. Now, if you apply the same formula, base address plus I minus 5 multiplied by number of columns plus J minus 5 whole multiplied by size of each element. If I would like to calculate address of 5, 7, what is actually address of 5, 7? 1008. Do I get that or not? Let us check using formula. This is 1000 plus I is what? 5 minus 5 whole multiplied by 3 plus J is 7 minus 5 whole multiplied by 4. This is 1000 plus 0 multiplied by 3 plus 7 minus 5 is 2 whole multiplied by 4. 2 into 4 is 8. So I am getting 1008. Yes. So yes, this formula is working when the index start from 5. So I minus 5, J minus 5, when you replace instead of I and J, definitely I will get the address of any element correctly. In the same way, if the indexing start from minus 3, I minus of minus 3, J minus of minus 3. But it can be given like row index is from 2, column index is from 3. Of course, it is possible. So row index is from 2, column index from 3. So 2, 3, 2, 4, 2, 5, these are the indices. 3, 2, sorry, 3, 3, 3, 4, 3, 5, these are the indices. Addresses are same, 1000, 1004, 1008, 12, 16 and 20. Why I have done I minus 1, I minus 5? Because indexing is starting from 5. Similarly, why I have done I minus 5, why I have done row index started from 5. Similarly, why I have done J minus 5? Column index also started from 5. Here, row index started from 1, 2, column index starting from 3. So, what I do? Base address plus I minus 2, because row index started from 2 plus j minus 3 because column index started from 3, right? So this is what address of A of ij. Let us check. You would like to find out address of 3, 4. That is equal to base address plus 3 minus 2 whole into 3 plus j 4 minus 3 whole multiplied by 4. Size of each element is 4 bytes I am taking. 1000 plus 3 minus 2, 1 into 3 plus 1 whole into 4. This is 1000 plus 3 plus 1, 4 into 4, 16, 1016. Is it not 1016? Address of 3, 4. Yeah. So, this is what the formula I use. I minus 2, j minus 3. Arif Sheikh, very simple. With what starting number, like you say lower bound means with what number you are starting, that number you subtract from the row index, column index. Okay, Arif Sheikh. Arif Sheikh, please respond. I am assuming the base address as 1000. You may assume from some other number also, your wish. You may assume some other number also better. Arjun Kumar. Okay. So, now if the row index starts from some x, column index starts from some y. X can be equal to y or can be different also. And for any base address, for any row index, for any column index, how do you find out address of A of ij? That is I minus x multiplied by number of columns, j minus y whole multiplied by size of each element. Size of each element. Clear? Okay. Now, in the same way, you can also understand in the same way from 0, from 1, from 2, from 5, from some different number for both index or for different indices in the column major order also. Column major order also. That I am leaving for your practice because C programming follow row major order only. Language like Fortran followed column major order. For the GATE exam, definitely column major order we need not to expect. But as you are learning not only from the GATE perspective, just you are learning it as a language. For your idea, I am giving the general formula for column major order and how it is evolved. You can understand with the experiment from 0, from 1, from I, from K, from X, from Y. Got it? Okay, this you experiment, you will get it. But here formula is not same, guys. Instead of I into C, row index into number of columns, what you got? Column index multiplied by number of rows, because it is a column major order. Similarly, instead of I minus X, J minus Y. Okay. So, this is the general formula for column major order, and how it is coming, is it working or not, you can try. I will show you. If I am taking 2 rows, 3 columns, first column values will come. Suppose if I am taking index, row index from, let's say, -2, column index from, let us say, -9 or +9, any number you can take, no? Let's say I am taking column index from +9. First column values will store. That means 9 -2, 9 -3. 2 rows only. So these would be the first column, because I will show you we are having 2 rows, 3 columns, and the row index started from -2, -2, -3. Column index started from -2, -1, because growing, no, -1. Column index started from 9, +9. So 9, 10, 11. So -2, 9, -2, 9, -3, 55, 66. Minus. Oh, I have written in reverse, sorry. Row index started from -2 and the column index started from 9. So -2, 9 and -1, 9. Similarly, next second column values, that is -2, 10, -1, 10. Third column values, -2, 11, -1, 11. Right? Now you want to check address of any. Let's say I would like to check address of X of let's say -1, 11. Last element address, or 10. Your wish, you can take any. Here base address I have taken as 1000. So it is 1000 plus J is what? 10 minus started from 9. So 10 minus 9 into number of rows 2 plus I is what? -1, and the numbering started from -2. Whole multiplied by size of each element is 4. So this is 1000 plus 10 minus 9 is 1, 1 into 2 plus -1 minus of -2, that is -1 plus 2, that is 1, whole into 4. So this is 1000 plus 2 into 1, 2 plus 1, 3 into 4, that is 1012. This is correct? Address of minus 110 is 1012. Of course, yes. So, it is the formula for column major order. And you can do further experiment on it. So, guys, I believe now you will be confident after understanding, practicing, analyzing all, starting from the scratch. One dimensional list, index from 0, index from 1, index from 5, index from minus 3, index from k. So, how do you find address of any element of 1D array? Similarly, address of any element of 2D array in the row major order, in the column major order, irrespective of from where the index starts, row index, column index. Right? That's all, guys, for today. And the next class is going to be tomorrow, and tomorrow we are going to discuss character arrays in C. Of course, that is a string, but string as a character array, not as a pointer, not as character pointer. As character array, we will discuss strings tomorrow, sharp at 9 p.m. Wish you all a happy coding, keep learning, keep growing, dear friends. I believe you have enjoyed this session and learned how to find address of any element in 1D array, 2D arrays. In the same way, if you start analyzing for any dimensional array, you will be easily able to form the formula, generic formula for any dimensional arrays. Okay? This is my Telegram and Instagram group links. You may connect with me to through these Telegram and Instagram group links. If you have not joined yet, please do join. Thank you so much for joining the session. Keep liking, keep sharing, and subscribe to our BYJU'S exam prep channel for more and more useful sessions like this. And if you don't want to miss any, please do enable your notifications. Okay? So thank you, Arjun, Mani, Arif Sheikh, and everybody who have attended live and listened to me patiently till the end of the session. Keep attending the sessions regularly and try to circulate this session information to your friends, because it's a free series. Let this series, these classes benefit as many as possible. Okay? Thank you, guys. See you tomorrow sharp at 9 p.m. And if any NIELIT aspirant is here, from tomorrow I am starting a practice series, free practice series, and I will be giving 200 questions practice for NIELIT aspirants on our BYJU'S exam prep app. I repeat, on our BYJU'S exam prep app, I am starting a NIELIT practice series from tomorrow sharp at 8 p.m. Sharp at 8 p.m. means just before this class. And if you know any NIELIT aspirant, please circulate this info to them. I will give 200 practice questions from 5 different subjects. 40 questions from every subject I would share. Okay? Thank you, guys. Good night, everyone. Take care. Bye-bye.